Look at exercise 5.1.27. Here we have a function here. F of x is equals to ax squared plus bx plus c. And we get a lot of information here, but we find an expression for the derivative. And then I just find the derivative here. I keep the constant a. A is just a constant here. Then I find the derivative of x squared, which is 2x. Then I find the derivative of bx, and remember, if I find the derivative of 5x, that is 5. Find the derivative of 3x, that is 3. So the derivative of b times x has to be b. And I just write this as 2ax plus b. So here's the derivative, like this. And we actually know that when x is 3, the tangent line has slope 7, which means that, remember, if I put a number into the derivative, what do I get? Remember, the derivative is also called the gradient function or stigningstalsfunction. So if I put a number into the derivative, I get stigningstallet till tangenten. I get the slope of the tangent line. So now that f derivative of 3 is equals to 7. And in the same way, I know that when x is 0, the gradient is 4. So then I first put in 3 into f of x here, into here, and then I get 2a times 3 plus b is equals to 7. So I get 6a plus b is equals to 7. That's the first equation. Remember, here we have two unknowns, so I have to have one equation. This will give me this equation, but I need one more equation. And if I put 0 into x here, I get 2a times 0 plus b is equals to, and I know the answer should be 4. And this will just go away, so I get b is equals to 4. So then I have b, but I also need a here. But then I can put b in here, so I get from equation 1 that 6a plus b, which I know is 4, is equals to 7. So I get 6a, move this over, change sign, so I get 3, divide by 6, so I get 3 over 6, which is of course the same as 1/2. So the answer here is that the derivative is 2 times 1/2 times x plus b, right? There we go. Put in a here and b here. So I get 2 times 1/2, which is 1, so I get 1x plus 4. That is the derivative. So that was exercise A. And then we should find the maximum, the extreme maximum or minimum point to this graph of f. And of course, if we want to find maximum or minimum points, we can put the derivative, which is x plus 4, that's the derivative, equals to 0. And we see that we get x is minus 4. So this means that when x is minus 4, the function either has a minimum point or a maximum point. And remember, this is a parabola, this one, and a is the same a as we found somewhere here. So I know that f of x is equals to 1/2. A was 1/2, remember that? X squared plus bx, which is 4, plus c, I don't know what c is. But the thing is here that I see that the term at x squared is positive, which means that f of x is smiling. So this means that this is a minimum point. So we have a minimum point when x is minus 4. F has a minimum point when x is minus 4. Use the graph of the derivative. Yes, okay. Yeah, so b was just this, and then c was the thing I did here. Okay, use the graph of derivative. Sorry. So I show that it is a minimum point by looking at this, but I should use the graph of the derivative. And this is the derivative. This is a straight line. The constant term is 4, which means that the line will cross the y-axis in 4. The gradient here is 1. So if I go 1 to the right, I go 1 up. So this graph will look something like this. And if I draw it properly, I will see that the 0 point, I put it equals to 0, so I found the 0 point is minus 4, like this. And I see that the graph of the derivative is first negative and then positive, which means that f is first decreasing, then increasing. So by looking at the graph of derivative, I see that this is a minimum point. So that was exercise 5.127.